Hello everyone, I'm François from Shakmat, and this is the Bishop's Miscellany MK2. It is a dual CV gate engine, and it is a powerful tool to create and mangle sequences in an intuitive and performative way. It is made of a dual CV gate stepped recorder, a CV gate processor, and a sequence generator and regenerator. As it has a non-volatile memory, it can also load and save sequences. We know this video is pretty long, but you don't need to watch the full video to start enjoying or understanding what the Bishop Miscellany is doing. The first 10 minutes will give you a good idea of what you can do with the Bishop's Miscellany MK2. Let's first have a look at the Bishop Miscellany as a CV gate recorder. Let's analyze a bit this patch. So we have a clock opone, which is providing a clock to a 4-bricks rook and the Bishop's Miscellany. The 4-bricks rook is driving drum modules, which are the battering ram, lancer's latch, and archer's rake. So we can have a tempo reference to record our CV gate pattern in the Bishop's Miscellany. We have a CV gate keyboard connected to the Bishop's Miscellany. The first channel output of the Bishop's Miscellany is going to the volt octave input of a Banshee reach. The gate output of the Bishop's Miscellany is going to the triple steeple, which is controlling the Centaur's gate. So first channel of the Centaur's gate is the filters, the second one is a VCA, and the Banshee reach is going to the Centaur's gate, so filter and VCA. Before recording, we have to check the main page of the Bishop's Miscellany. First item to check in this menu is the sequence length, which can go from 1 step to 64 steps. We'll stick with a 16-step sequence for now. The second item is the clock divider, which divides the clock input. We can set it to a value from 1 to 16, but we will keep it at 1 for now. Let's start the clock opone so we can hear a beat. In order to record our CV gate keyboard, we have to press and hold the external rec button, and as you can see, the progression bar is now running. When the external recording is engaged, now the output of the Bishop's Miscellany are following the inputs. If you don't want to keep pushing the external rec button, use the hold and external rec combo, but for now we will simply hold the external rec button manually. And let's record a sequence. As you can hear, the sequence is looped. Let's now have a look to the other items of the main menu page. So the first one is the semitones transposition. C means no transposition, as C sharp will mean one semitone transposition. Can go now to D for 2 semitones, and so on. So let's stick to no transposition. Second one is the octave transposition from -3 to +3. The next item is quantization, so we can here choose a scale for the quantizer. So we have no quantization, semitones, octave, and a lot of different scales you can choose from. As we recorded a CV gate keyboard, we will stick now to no quantization. Let's now check the Bishop's Miscellany MK2 process section. So what is it first? The process section is a set of tools that you can find in many modern sequencers. Tools such as slide, ratchet, gate length variation, vibrato, and also adding noise to the CV output. If you want to choose a process, you can, on this main page, go to the last item, which is the process, and choose a process from here. Alternatively, you can also go to the process page. So a few words about the navigation. To go through different pages of the module, just select the title and scroll to the different pages. Here we can go to the process page, for example. Another quicker way to navigate through the pages is to hold the nav button and turning the encoder, and you go directly to the different pages of the module. And there is a third way to go quicker in some pages using the nav button and some shortcuts to go to the process page. For example, press the nav button along the process button and you go directly to the process page. Last but not least, by pressing the nav button alone, you go to the main page. But we're here to talk about the process section, so let's go to the process page. Here you can choose a process. The second item in this page is a mode, which is different for each process. The bottom of the screen shows the value and the function of the process potentiometer. So first process is a slide. We have two different modes for the slide, which are constant time or constant rate. Let's keep constant time for now, and let's now activate the process by pressing the process button. As you can hear, we are now adding slide to the sequence. By pressing the Hold and Process button, you can simply hold the process. There is a more interesting thing to do with a process. You can also record a process sequence. So to record a process sequence, we will use the internal rec button. So internal rec button means you can record almost anything you have on the panel of the Bishop's Miscellany, mainly with the process and the region. So let's hold this internal rec button and let's now play with the process section, so the slide for now. And we have now a slide pattern running upon our sequence. If you don't like your slide sequence, simply press Erase along the process button when the slide process is selected on the screen. Let's now check the next process in the list, which is the gate length. We use the gate length in the same way as the slide, so hold the button and play with it. So we can go for very short triggers to full clock period gates. And we can of course now record a gate length sequence. Let's spice up things by adding also a slide sequence. Let's now check the third process, which is a ratchet. And let's directly record a ratchet sequence. Then we have a vibrato. Process potentiometer controls the depth of the vibrato. With encoder, you can choose the speed of the vibrato, and we can go to FM territories. Okay, let's erase the vibrato sequence. And let's check the last process, which is a noise, which simply adds noise to the CV output. Let's now talk about the Regent section of the Bishop's Miscellany MK2. So what's the Regent section? The Regent section is actually a set of algorithms which either allows to generate sequences or to regenerate/mangle existing sequences. There are several ways to select a Regent algorithm. The first one is in the main page, go to the Regent section and choose a Regent algorithm. Or for a full visual feedback of your Regent algorithm, go to the Regent page. The shortcut is a nav button pressed along the Regent button. This page shows the selected Regent algorithm and also shows the function of the two Regent potentiometers. So you have on the screen the functions and also the values of the potentiometers. When scrolling to the different algorithms, you can see the title of the screen changing. When the title is Gen, it's a generative algorithm. When the title is Regen, it's a regenerative algorithm which mangles an existing sequence. Let's now one by one check all the Regen algorithms, and we will start with the first generative algorithm, random 1. Let's start a beat in order to have a tempo reference. Let's enable the random algorithm by pressing this button, which is the Regen button. You can hold the generation and regeneration by pressing the Hold button along the Regen button. For this algorithm, we have a change parameter for the X potentiometer. This potentiometer gives a probability to have a new random voltage and a trigger. And the second potentiometer, the Y regen potentiometer, gives a range of the CV output. And of course, you can now record the generated sequence. Let's now check the second algorithm, which is random 2. So random 2 is a bit different from random 1, as the trigger generated is based on musical tables, as the CV output has a more musical random distribution. So let's enable now the random 2. And let's now record a new sequence. As you just saw, I can, of course, mangle the two regen potentiometers while recording a generated sequence. Third generative algorithm is the arpeggiator. So the length of the arpeggiator is based on the length of the sequence. So here we have a 16-step sequence. Let's stick to that. And for an arpeggiator, let's go and choose a scale for the quantizer. Let's enable the arpeggiation and let's record it. The first potentiometer allows to choose different modes: up, down, and up-down, which is pendulum. The regen Y potentiometer sets the range of the arpeggiator. Fourth algorithm is the pass algorithm, which is a homemade algorithm based on the way musicians usually improvise. The two controls control the ornament and the jump settings. I can use the generative algorithms to make breaks or record small bits of generation inside the previously recorded arpeggiator. The last generative algorithm is the knob recording. So the Y potentiometer is the CV output you want to record. The X potentiometer sets the threshold you need in the CV output to generate a trigger. So with low threshold value, you generate a trigger at each change. With higher threshold values, you need wider move of the Y potentiometer in order to generate triggers. Let's record a sequence now. Again, what we saw until now are generative algorithms, which generate sequences from nothing. We are going to see now the regenerative algorithms. Let's create another sequence in order to understand the regenerative algorithms. We will first erase the sequence by pressing the erase button along the channel button of the channel you want to erase, so channel 1 for now. Let's choose now the arpeggiator algorithm, so we will have a clearer idea of what the regen algorithms are doing. And let's now go to the first regen algorithm, the range algorithm. So again, the regen algorithms are mangling the existing sequence. The first control of the range algorithm is the gain. The gain allows to extend or reduce the range of the CV output. Of course, the controls are pre-quantization, so everything stays in scale. The second parameter now is the offset, which allows to offset the CV sequence. The second regen algorithm is the speed algorithm. First control allows to read the sequence forward or backward, as the second control is the speed, meaning we will now skip some steps and the sequence will be shorter. Let's activate the algorithm. Regen algorithms can be used to add variations to the sequence, but you can also use them to regenerate the sequence and recreate another sequence. Press the internal recording with the regen button. Third regen algorithm is the rate algorithm. The rate algorithm acts as a rate reducer for audio, but here it is for sequences. So basically we are going to skip some steps and repeat the steps we are playing. The Y control is a rate reduction. So we have a rate reduction of 4, so we are keeping one step on 4. The X controls allows to choose which one of the 4 steps you are keeping. Let's go now to the next regenerative algorithm, which is a slide. It's an heritage of the Bishop's Miscellany Mark I. It basically cuts the sequence into different slices, like a sampler. The regen Y potentiometers act on the length of the slices, as the X control selects which slice you are playing. Let's set the length control to 4 steps, for example. And now we can scan the sequence 4 step by 4 steps. Next regen algorithm is a random slice. The Y control still acts on the length of the slice, as the X control acts on the probability to go to another slice when a slice is finished. So let's set first the length. Let's stick to 4 steps for now. Let's check now the next algorithm, which is the delay algorithm. So this algorithm will delay and offset the sequence. So you have the Y control acting as a transpose and the X control on the delay per steps. Later in this video, we will turn the Bishop's Miscellany Mark II into a CV gate multi-effect using the delay on external patterns. Last algorithm is a remember algorithm. This algorithm replaces some part of the sequence by other parts of the sequence. The 2 controls act on different probabilities. The Y potentiometer acts on the probability of starting reading another part of the sequence, while the X controls set the probability to go back to the normal sequence playing. If we set the key probability at 0%, we will mostly replace some independent steps by other steps. That's all the regen. And if we raise the key probability value, we will mostly replace part of the sequence by other parts of the sequence. The Bishop's Miscellany Mark II is a dual-channel CV gate engine. So let's now check how to work with the 2 channels. Everything we've talked about until now was about the first channel, but we can do exactly the same with the channel 2. So to go from one channel to the other, simply press the channel button and the active channel will have its button on. We've prepared a small patch with a Delptronics nunchuk, which is an awesome controller in order to control 2 CV and 2 gates at the same time. We're sending the X-axis of the joystick into the first channel CV input, and the big button is sent into the first channel gate input of the Bishop Miscellany. Let's record something. The Y-axis of the joystick and the other button are sent into the other channel inputs. Let's erase the 2 sequences now. What could be convenient with a device having 2 CV and 2 gates like the nunchuk is to be able to record the 2 channels at the same time. This is where the link feature is useful. To enable the link feature, simply press the 2 channels button at the same time. You can still select one channel, but you can see the other one is dimmed. And now we can record the 2 channels at the same time. There are actually several linking modes. We will talk about this at the end of this video. The Bishop's Miscellany has a sequence editor, which is a great tool to edit your sequence in a destructive way. The shortcut to open the Edit Sequence page is the nav button along the channel button you want to edit. So we prepared a beat with a sequence. The first edit tool is a shift sequence, so you can shift the sequence step by step, so backward or forward. So press the encoder, then choose the number of steps you want to shift the sequence. You already have a pre-listen of the shifting. And while you're happy, just repress the encoder and press confirm or cancel. Then we have the reverse sequence, which simply allows to reverse the sequence, so playing it backward or forward. Let's reverse it again, so we have the original sequence back. Then you can duplicate the sequence, and you have to choose the number of steps you want to duplicate the sequence on. We are going to duplicate the 16-step sequence on 64 steps here. Press confirm. And let's go back to the main menu, and as you can see, we have a sequence length of 64 steps. Now the original loop is running 4 times, and we can add a variation at the end. Copy sequence allows to copy the sequence on the active channel to the other channel. Next option is copy parameter. We will copy all the main menu parameters from one channel to the other. As you can see, the sequencer settings are not the same. The last edit tool is copy sequence and parameter. It will execute the 2 latest edit tools at the same time. The Bishop's Miscellany MK2 has a non-volatile memory on the SD card. This SD card, among other data, allows to store sequences. It is possible to store up to 999 sequences per project. We will see a bit later what a project is in this video. To manage sequences in memory, let's go to the memory page. The shortcut is the nav button pressed with the Alt button. In this page, you can load and save sequences for both channels, and also you can load and save playlists. We will see a bit later in this video what a playlist is. So let's hear a pattern, and we have a background beat. Let's say first we want to save this pattern. Let's go on the save icon for the first channel. Let's confirm by clicking the encoder, and let's now select a sequence number in memory. You can have up to 999 sequences, and we will decide to go now for sequence number 1. Click to confirm the number, and now you can either confirm or cancel the save operation. Let's now confirm for now. Let's now erase the sequence playing on channel 1, and let's load the sequence we just saved. So let's click on load. The sequence we just saved was sequence number 1. We can now confirm or cancel. We want to confirm now, and we have our sequence back. Let's now modify this sequence with, for example, a process. So let's go to the process page. Let's record a slide sequence. So we just modify the sequence. Let's go back to the memory page, and as you can see, the sequence number has an asterisk, which means the sequence has been modified since the load operation. Load and save operation for the second channel works the same. So let's go to the load icon for second channel or save icon, and then you're gonna load and save sequences for the second channel. You can of course save a sequence on channel number 1 and load it after on channel number 2. The 2 last icons at the bottom of the screen allows to load and save playlists. As we just mentioned in the previous section of this video, the Bishop's Miscellany MK2 has a playlist mode. This mode allows to organize the sequence in memory in the order you want, which allows to prepare a live set or to compose different parts of a track. The shortcut to go in the playlist page is to press the nav button along the Alt button. So first we will go to the memory page, but if you press this combo again, you will be in the playlist page. If you're coming from another menu page, pressing nav and Alt button at the same time will send you back on the last page you had with the shortcut, so either playlist or memory page. The playlist is made of 16 slots where you can put any sequence for both channels. We prepared 4 different sequences, 2 to go on the first channel and 2 also to go on the second channel. To edit a playlist slot, simply press and hold the encoder. Now the slot visualization is inverted and you can select a sequence number. So we have 4 sequences, 1, 2, 101 and 102. Let's put the first sequence on the first slot of the first channel of the playlist. Now the erase and all button are for the playlist the shortcut for next and for play, but when you're editing you can also press the next button and then edit the next slot. And on the second slot of the playlist for the first channel we put the sequence number 2. Let's now go to the second channel where we just press channel number 2 to edit the playlist for the second channel. Let's put 102 on the second slot of the playlist for the second channel. Yes, 102 and 101 for the first slot of the second channel of the playlist. Keep in mind you have to save the playlist. To do so, let's go back to the memory page and let's go to the save playlist icon and let's save this on the playlist 1. As with sequences number, when you change something to a playlist, an asterisk is appearing just next to the number of the playlist. Note a project allows a maximum of 99 playlists. Let's now use the playlist we just created. Let's press for both channels on the slot in the playlist and the sequence are going to start when we press play. There we go. A reset signal received at the reset input could resynchronize the 2 sequences for both channels. Also, please note we are for the playlist now in a mode called the setlist mode, so the patterns are just looping and we need to manually change them. There is also a tracker mode we will see later in this video, where the module goes to the next sequence when a sequence is done. This allows to make structures. So let's manually shift to the second sequence for the first channel. Let's go to the second slot for the second channel, so let's switch channel first. This time we'll be using those 2 buttons which are shortcut for the playlist. The erase button is the next slot, as the all button is the launch slot. So let's press first on next slot and then press the play button, so the launch sequence. In the option menu, you can set different behaviors. For example, you can set the 2 channels to be launched at the same time. You can also decide if you want your pattern starting after a launch at the next clock or at the end of the sequence. The Bishop's Miscellany has 4 assignable CV inputs. Those inputs can be assigned to a lot of different parameters. To set those assignations, let's go to the ACV menu page. There is no shortcut for this page. The way this menu is organized is we have different families of assignations. The first family of assignation is a transport family, so you have to first validate the family. Now we have a choice of several transport assignations. Here we have run 1, which is the assignation of ACVA. So each time a I signal, a I gate is received in the ACVA, the sequence will be running, otherwise the sequence is not running. So we have to validate the assignation by clicking on it. And so as you can see, each time my fader is up, the sequence is running. Run 2 is for the second channel, run 1, 2 for both channels at a time, And then we have activity, which is pretty much the same as run. But with run, there is a reset of the sequence at the beginning of the I gate. You can also assign the external recording for channel 1 or channel 2 or for both channels to a assignable CV input. And then you can clock or reset the second channel with independent inputs. If I click no, I disable the activity on channel 1 input, so the sequence is running again. So let's now go to the second family, which is the playlist family, where we can address by CV a sequence in a playlist. So you can do it for channel 1, 2 on both channels at a time. Then you have the next assignation, which means the ACV input is supposed now to receive a trigger in order for the playlist to go to the next slot, again for channel 1 or 2 or both at a time. Let's now check the next family, which is the compute family. This family allows to add signals to the CV outputs. So let's confirm first the family. First option is the addition pre-quantizer for channel 1, 2 both channel at a time. Then we have the post-quantizer channel 1, 2 both channel at a time. And the last option is the octave switch for channel 1, 2 both channel at a time. Let's check the pre-quantizer summing. As we are adding the voltage pre-quantizer, we are keeping everything in tune. And as for fun, let's record a loop with a Griffin's clause in order to transpose every X bars. Let's have a look at a different family and let's erase this loop on the Griffin's clause. Next family is process, so you can assign any assignable CV input to any parameter or button of the process section. So slide, it's like having a gate doing the same job as a manual button. Then you have the potentiometer for channel 1, channel 2 both channel at a time, gate length, activity and potentiometer, and so on. Note when doing internal recording with process, the signal received the ACV input will be recorded. So let's go now to the next family, which is the region family, and you will just work with the active algorithm. Same thing, you can, so first let's select the family and let's now switch between the different options, which are the control of the button or every potentiometer for channel 1, channel 2, and again both channels at a time. So let's do a quick example with on 1, for example. So the fader is activating the region for the first channel. Okay, let's set the settings. So now, every time the fader will be up, we'll have a random generation instead of playing the sequence. So here we could play with the Griffin's clause, and let's say each end of X bars we want a random variation. As we mentioned earlier in this video, the memory of the Bishop's Miscellany is structured with projects. A project is a pool of 999 sequences and 99 playlists, but also the different assignations of the CV input, which are per project and not per sequence, and also a project contains the different stored options. So let's now go to the project page, which is the last page. Here you can create a new project, load an existing project, or duplicate the active project. As you can see, there is no save project. Actually, the assignable CV input and the options are automatically stored when edited, and you have also to save manually every sequence or all the playlists you are changing while working with the memory. Let's now talk Select Bus. Let's go first to the option page, where you have the first option in the menu, which allows to enable or disable the Select Bus as a receiver. So the Bishop's Miscellany is able to understand program change messages received into the ribbon cable from another module which is a transmitter, such as the Harlequin's context, which sends the messages to the Bishop's Miscellany. Those messages will allow to address automatically the slot into a playlist. With all the features we described for the Bishop Miscellany MK2, we actually can do something quite unique with it, as we can turn the module into a dual-channel CV gate multi-effect, meaning the module can mangle sequences received at the input in real time. So let's go first in the option menu and let's configure the source of the channel 2. Obviously, you could expect the second channel to have as inputs the CV and gate inputs number 2. So this is the case when we are setting it as in 2. So in listen mode and record mode, channel 2 has as a source CV and gate 2, but you can set it also as in 1. Which is pretty useful with a setup made of a CV gate keyboard, which drives a Bishop's Miscellany, which controls 2 different voices. Last option is to have the second channel fed by the output of the first channel. For our multi-effect application, what we're gonna do is to set the second channel having as a source input 1. The goal is to mangle one sequence in order to have 3 different correlated sequences. So the Griffin's clause is providing a sequence to the bar quartet, and CV out and gate out are going to a battering ram, and the battering ram is set in high pitch mode, so we can have a nice melody with it. The sequence sent to the battering ram is also sent into the first input of the Bishop's Miscellany, which then goes into the 2 channels. Let's press record and hold it, so we can hear the first channel of the Bishop's Miscellany is playing exactly the same sequence. Let's do the same for the second channel. Note both channels are set with a scale. Keeping the recording on allows to listen to the input. We could be also in listen mode for this application. Let's now go apply live a regen. So let's go to the regen page. We have a delay. The delay regen delays the sequence per step and also transpose with a transposition pre-quantizer. Let's activate it. As you can hear, the sequence is delayed. Also keep in mind the delay transposition is done pre-quantizer and we have a scale selected. Note this kind of patch works well when you have few notes on the source, like the bar quartet is just having 2 notes. Let's now go to the second channel. We also have a delay and let's enable it. The incoming sequence can be mangled by regen, but also by processes. So let's activate the slide for the second channel. And for the first channel, let's go with a vibrato, for example. Here, the incoming sequence is mangled by a static process, but you could also apply a process sequence to have more dynamic results. Another variation to this patch you could try is to have the second channel sourced by the output of the first channel. So all the change you would do on the first channel would also affect the second channel, and the second channel would have its own settings regarding the delay and the transposition. If you change the incoming sequence, the 3 sequences will change at a time. And let's go back to the original sequence. As we explained earlier in this video while checking the playlist page, there are several options regarding the playlist. So let's go now in the option menu. In the option menu, you have 3 different options regarding the playlists. So the first one is the playlist mode. This defines the way the patterns will be played in the playlist. So the first option is list, meaning you have to launch manually every pattern. And the second option is a tracker mode, meaning each time a sequence reaches its end, the playlist will go to the next sequence. As with a classical tracker, this module also allows to create what we call island. We will see it later in this video. Next option is a playlist launch mode. This can be set as single or both channels. Single channel means you launch the sequences independently in the playlist. Both channels means you're launching both channels at a time. Third option is the playlist next option. Basically, it sets how the module behaves when launching a sequence in the playlist. First option is end of sequence. So the playing sequence needs to reach its end before playing the next sequence. Second option is next clock. The next sequence will start to play when receiving the next clock. And last option is next clock reset. In this case, you work both with the reset and clock input. Let's now have a deeper look at the playlist mode. Let's edit the playlist first. So we prepare two different patterns, number 2, 3, 4. So let's have the pattern number 2 on the first dot of the playlist. On the next one, we will have pattern number 3. Let's go to pattern number 2, pattern number 3, and then let's place 2 times pattern number 4. When working with a tracker, we created what we call an island made of 2, 3, 2, 3, 4, 4, and then we don't have any sequence. So when reaching the end of the second pattern number 4, the playlist will loop to the beginning, so the pattern number 2. Let's set the playlist mode in tracker mode now. Let's go back to the playlist page and let's launch the playlist. And of course, let's press play on our clock upon. As you can hear, sequences are the same with different semitones transposition. As you just saw, at the end of the island, the module goes back at the first sequence of the island. You can have several islands per playlist. Let's now go further into the option menu in order to talk about the different configurations for the CV inputs and outputs. So channel 1 and 2 output option and channel 1 and 2 input options. For the output option, you can choose different output norms, volt octave for Eurorack and a lot of different synthesizers. Second option is Hertz per volt, meaning the Bishop's Miscellany can, for example, control your MS-20. And last option is Buchla 1.2 volt per octave if you need to control your Buchla system. So for channel 2, you have exactly the same options. Next option is channel 1 input range. There are 2 different settings for this option. First one is 0 to 5 volt and second one -3 to +7 volt. 0 to 5 volt offers a much more limited range, but also offers more precision into capturing CV. This can be useful if you're working with microtuning and want your Bishop's Miscellany able to replicate the microtuning. -3 to +7 volts means more range, but a bit less accuracy. If you use a quantizer, you don't care about this. Now you have for the channel 2 the same option, so 0.5 or -3 to +7 volt. So let's keep on moving in the options menu. The 3 next options set different behaviors for the main menu page. So first one is default length. What happens when we erase a channel? The length can go to 16 steps, automatic length or quantized length. Those 2 latest options means the recording length will be set by the length of the recording. Auto length can lead to any length in terms of steps. As quantized length means the available lengths are quantized to a certain time signature, which can be a 4/4, 3/4, 5/4, 6/4, 7/4. So in 4/4 times signature, the quantization when the default length is set in quantized length will be a certain number of bars with a 4/4 time signature. Next option is default division. There are two modes for this option, 1 or keep the same division as before. Okay, let's go back to the default length, so quantized length, and let's erase the channel. So as you can see, the length is now quantized length. Let's start a beat. So let's say you're in a case where you don't really know what you want to play right now, which sequence you want to play. So there is a first thing which is pretty useful for that is the listen mode. Press the external rec button along the channel button, and you're just gonna listen to the input without affecting any recording buffer. As you can see, the external record LED is now slowly pulsing. I have a keyboard patched to my Bishop's Miscellany, so let's find what we want to loop. No, still searching. Okay, let's loop this. As you saw, the sequence length was set by the recording time, and it was quantized in a certain number of 4/4 bars. Let's erase the sequence for another example. Okay, let's find another riff. As you saw, I released the button way before the end of the 4 bars, and it's still quantized at 4 bars. The Bishop's Miscellany MK2 features an undo operation with 1 level. It allows to cancel the latest recording operation. So here we have a sequence running on channel 1. Let's record something else with a regenerative algorithm. And now you want to go back to the previous sequence. Press both erase and alt button at the same time, and you will cancel the latest recording. We saw earlier in this video it is possible to link the two channels. There are actually 3 different modes for the channel link. First link mode is the independent link, second one shared algo, and the last one full link. So let's go to the independent link. In this mode, when linked, the two channels can have independent settings regarding what's happening on the main menu page. You can also have different regen algorithms and also different pointed process. Let's go to the second link mode, so shared algo. In this mode, the two channels will share the same algorithm for the regen part and also for the process part. With the shared algo mode, you can have different settings for the main page and also different values for the process and regen algorithms. Now, full link, where we will have the same parameters on the main menu page. So let's link the channels. And we have the exact same settings on the two channels, same for the regen part, with the same algo and same parameters. This mode allows, for example, to turn the Bishop's Miscellany MK2 into a dual generative sequencer. We have a clock coming in the input. Both channels are sending a CV gate to 2 different voices made of envelope VCO and LPG. And let's generate a random dual random melody. Potentiometer applies on both channels. We are in full link. And let's record a sequence. Let's now switch to a regenerative algorithm. And this is it for today. Thank you for watching, and bye bye!